Alrighty, let's see what we got here. Two furthest houses with different colors. Easy, okay. There are n houses evenly lined up on a street, and each house is beautifully painted. You're given a zero-index integer array colors of length n, where colors I represents the ith house. Return the maximum distance between two houses with different colors. The distance I and j. Okay, so distance is measured as the difference between the positions, the absolute value of the distance. So here they're all the same colors except for 3, so the maximum would either be between 0 and 3 or 3 and 6, which is both 3. Here the colors maybe between 3 and 1. No, because it's between 0 and 1 would be that one. Is this just 1? Maximum distance between, yeah, it's just 1. No, is there 4? Oh, these, okay, it's not the nearest of the color, it's just any color. Okay, I guess that makes sense. It's not like 1 here, so 4 there, and then 1 here. Sure. This seems like a hash map. I just need to store the earliest of the color. No, that's not right. This should be pretty simple, but why am I blinking here? So the farthest distance where something different has occurred. So 1, 8 makes it 1 because 8 and 1 are different. 3 and 1 are different, so it's 2. 8 and 1 are different, so it's 3. I feel like I probably want to start with the maximum and see it and break whenever I see a difference. So starting with the 1 and 3, so the n values, since they're different, then I know that they're going to be perfect. How do I iterate over that though? So then at that point I can either move the front end or the back end. At that point I can move either the front end or the back end. So, okay, yeah. I either find the first non-same value in the front to pair with the back, or the first non-value in the back to pair with the front, because in order for the colors to not initially just have the length of it be the maximum distance, the first and last would have to be the same color. So then I move the pointer in the front to wherever it's not the same color. So it would be the first non-same color in the front. And then I also move the front or the back pointer to the forward to the first non of that color. Yeah, okay, I think that works. So if colors, let's say n is equal to the length of the list, actually maybe yeah, if colors of 0 does not equal colors of the end, return, so that means they're different, so return n minus 1 because it's 0 indexed. No, that's because that's just the difference between those two. Yeah, and then I need to move the pointers. So let's say p1 is equal to 0. Actually, while p1 let's just say for p1 in range n, if P1 or colors of P1. Yeah, not equal to colors of 0. Then break. And then similarly for P2 in range n minus 1, minus 1, minus 1. So it's iterating backwards. Iterating from the last towards the front. Colors of P2 doesn't equal colors of 0 or -1. Break again, and then return the maximum of the difference between P1 and the last. So it'd be n minus P1 minus 1, or is this, yeah, I think it's n minus 1 minus P1. And just P2, I think. Or is it P2? Yes, P2. I think that works. Wow, if I am on something, and that on something was just a lot of tiredness. Okay. All right, sweet. I think there was other ways I could have done this, obviously, but they all get to the same point. Summary based on logic of problem. The only way that the length, or length minus 1, is not the answer is if the two colors at the ends, the start and the last of array, is the same color as in example 1. You then need to find the first non-same color from the start. Yeah, from the start, like iterating over the indexes from 0, 1, 2, 3, 4. Also find the first non-same color from the end, iterating backwards. Kind of iterating backwards from the last. Then find the larger distance between, kind of, let's say this first one, let's call it x, and let's call it y for the second one. What's y? These are the indices between indices x to end and y to start. Return that maximum distance. So yeah, P1 is the first non-same color from the start. P2 is the first non-same color from the end. That color being whatever the kind of same color is from the start and end. And then just return the maximum. Time complexity is going to be O of n. Since in the worst case, every index is iterated over. So like here, I had to iterate over all these indices to get 3. Doing constant work each time. Work in each iteration, in each loop. And then space complexity, this can be O of 1. as no extra space is needed. Alright, cool beans.